Every computer program is basically a message. But here's the thing we often forget. It has two totally different audiences. There's the machine it runs on, of course, but then there's the human, the person who has to read it, use it, and eventually fix it. Today, we're going to explore that other face, the one that speaks not to the machine, but to us.
Think about it. If you can't truly understand a piece of code, do you really possess it? Do you really control it? This idea is the foundation for everything we're about to dive into. This other face, it's not just a nice-to-have feature. It is the story the program tells to people. It's a narrative that's every bit as important as the machine's syntax, and it's what separates a genuinely useful tool from just a black box of pure frustration. If good documentation is so critical, why is so much of it just terrible? It turns out our whole approach to solving this problem has been fundamentally broken from the start. We have all been there, right? Staring at a screen of totally cryptic code written by a ghost from the past with zero guidance. And we get so frustrated and we promise ourselves we'll do better. We tell our teams, hey, document your code. We lecture, we plead, and it almost never ever works. That brings us to the million-dollar question. If just trying harder with the same old methods is a complete dead end, what's the alternative? The answer comes from this great story about a legendary salesman. Thomas J. Watson, Sr., the founder of IBM, used to tell this story about his early days. He'd failed to sell a single cash register, and he went back to his boss completely defeated. But the manager didn't give him a big speech. He just said, "Help me load some registers into the wagon." And they went out together, and the manager showed him how to do the job. He demonstrated it. And that is the real lesson here, isn't it? Lecturing is useless. The solution isn't to just try harder, it's to completely change the approach. It's all about demonstrating the how, not just demanding the what. So what does showing how actually look like for a computer program? It starts with a simple realization. Different people need completely different things from your documentation. Let's say you've got someone who just needs to use the program. For them, the nitty-gritty details are just noise. What they need is an overview, a map of the forest. What's this thing for? What does it need to run? How do I actually operate it? You're not describing every single leaf on every tree. Now, what about getting someone to believe in your program, to really trust it? For that, they need proof, and that means test cases. And not just the easy ones that always work. You need to show them the cases that push the boundaries, the stuff that's barely legitimate, and even the stuff that's barely illegitimate, just to prove the program is robust and handles errors like a champ. And finally, for the person who needs to get under the hood and actually modify the code, their needs are way deeper. They need the full internal overview, the architectural blueprint. And this isn't just a few comments here and there, it's the high-level structure, the key algorithms, and even notes from the original author about what they were thinking. Speaking of blueprints, we have to talk about one of the most oversold and honestly one of the most cursed tools in the history of programming. Let's not beat around the bush here. The source material for this explainer calls the detailed blow-by-blow flowchart an obsolete nuisance. And that's a pretty strong statement. But it's one that a lot of experienced developers would probably cheer for. They're almost never made before coding, are they? There's something you do after the fact to check a box. And the problem is simple. A detailed flowchart is just a super clumsy visual version of the code itself. It's tedious, it takes up a ton of space, and for any complex program, it becomes a multi-page monster. A structure graph, on the other hand, is different. It's a high-level map, a map of the components and how they all relate. It's a real tool for understanding, not just a redundant drafting exercise. The author uses this powerful analogy, quoting the Apostle Peter. The detailed flowchart is an unnecessary burden, a load that has proven way too heavy for anyone to actually carry. It's time to just set it down. If we're throwing out old, clunky tools like the detailed flowchart, what's the alternative? The most elegant solution of all is to aim for a program that actually documents itself. There's a basic principle in data processing that says you should never, ever try to keep two separate files synchronized. It is an absolute recipe for disaster. And yet, that is exactly what we do with our code and our documentation all the time. We have a machine-readable file and a separate human-readable one, and they just inevitably drift apart. The solution, then, is to just merge them. Instead of having two files that are constantly at war with each other, you create one single source of truth. The documentation lives right there, inside the code. That way, it's always handy, it's always synchronized, and it's so much more likely to actually be maintained. This leads us straight to the idea of a self-documenting program. This is code that tells its own story through its very structure. It uses thoughtful naming, clear formatting, and integrated comments to make its purpose and its function totally obvious to any human who reads it.
And this isn't some abstract pie-in-the-sky ideal. These are real, concrete techniques you can use right now. Use names that actually mean something. Use your formatting, your white space, show the logical blocks. Write paragraph comments that give a high-level overview, not just line-by-line noise. If you're using a well-known algorithm, just cite the source. Turn your variable declarations into a handy legend that explains what everything is for.
This all brings us to a final thought. We started with this idea that every program has two faces. The big shift, the big epiphany, is realizing they don't have to be separate. By making our code tell its own story, we're not just writing for the machine anymore. We're communicating with our future selves and with every single developer who will come after us. And when you think about it that way, that changes everything.